Okay, so think about this. Powering the absolute cutting edge of military aircraft, these incredibly high-performance machines,
Yeah.
but doing it sustainably. That's quite the puzzle, isn't it? It's really pushing engineering to its limits.
It absolutely is. When we talk about fuel for military jets, it's not just about uh, basic flight. These things operate at insane altitudes, pull incredible G-forces, face huge temperature swings. So finding a sustainable fuel that can, well, take that kind of punishment, that's a massive challenge.
And that's exactly what we're diving into today. We've got some really interesting source material here about how one major defense contractor is actually tackling this. They're working to integrate sustainable aviation fuel SAF
Mhm.
into their military ops. So our mission, yours and ours, is to really get under the hood here, understand the complexities, the tech, the logistics, the strategy involved in making military flight greener. We're basing this on detailed info about their specific program, the challenges and the potential wins.
Yeah, and it's key to remember, like you said, this deep dive focuses on one contractor's story. But the way they've approached it, it really gives us valuable clues about how this could work more broadly. Think of it as a really revealing case study for this whole specialized field.
Okay, let's get to the heart of it then. What were the big problems they were fundamentally trying to solve by bringing in DSAF? And sort of what was their game plan?
Well, the core issues were pretty clear. First, boosting energy security, meaning less dependence on traditional fossil fuels. That's critical. Second, the environmental side, a real push to cut down carbon emissions significantly. And third, strategically, building a more reliable and stable fuel supply chain. Their strategy, it really hinged on, well, strong partnerships and very focused tech development.
Partnerships. So it wasn't just them working away in their own labs.
Oh, definitely not. They were actively building bridges, working with government, like the Department of Defense, obviously, tapping into specialized research institutions, and linking up directly with biofuel producers who are doing innovative work. This whole network approach let them access the latest science and also, crucially, navigate the tricky regulatory landscape. The main goal was always to develop F that acts just like regular jet fuel, performs perfectly, but can handle those really tough military conditions.
Right, a drop-in replacement,
Yeah,
essentially, but sustainable.
exactly. Seamless integration was key.
Okay, so let's dig into the how then. What were the actual steps, the methods they use to get this military-grade sustainable fuel off the ground?
Their approach really stood on a few key pillars. First and foremost, a really significant sustained investment in advanced SAF R&D. They weren't just, grabbing off the shelf commercial stuff. They were looking into all sorts of new feedstocks, things like algae-based fuels, even synthetic fuels made from like captured carbon. That's pretty futuristic stuff.
Wow, algae and captured carbon.
Yeah, alongside more established pathways too, like HEFA that uses things like old cooking oil or agricultural waste. This R&D involved a lot of lab work, tons of complex computer modeling, really trying to nail down how these fuels would hold up under pressure. Stability, energy density, how they'd interact with the jet engines, all of it.
Fascinating. So it's not just finding something green, it have to perform no compromises.
Mhm.
What happened after that initial research push?
Well, the next pillar was strategic collaboration, working hand in glove with the DoD, specialist aviation labs, and crucially, standards bodies like ASTM International.
ASTM, they're the ones who set the fuel specs. Right?
Exactly. They give the official thumbs up. So that collaboration was vital for doing really rigorous testing, looking at everything, engine performance, detailed emissions tracking, the whole life cycle impact. These joint efforts were also super important for kind of speeding up the certification process needed for military use. You can't just put any fuel in a fighter jet.
Makes total sense.
Huh.
So, okay, they've researched it, they've tested it rigorously, but how do you make enough of it? Scalability, that sounds like a massive issue for the military.
Oh, it's huge. Absolutely. So their approach there involved putting strategic money into building biorefineries and other advanced production facilities. They also locked in long-term deals with SAF producers that help secure a steady supply and hopefully buffers against some of the price swings you often see with new tech.
Right, predictability is key for military planning.
Definitely. And they didn't forget the nuts and bolts either, planning upgrades for fuel storage and blending facilities right there at the air bases, making it easy to actually use the stuff.
Okay, and the elephant in the room, cost. Defense budgets are always tight. How did they handle the fact that SAF can be, well, more expensive, at least initially?
Yeah, cost efficiency was a major focus, no doubt. They really worked multiple angles. They went after financial support from defense agencies, leveraging government sustainability programs, energy security initiatives, things like that. Public-private partnerships were also a big piece of the puzzle, bringing in outside investment and know-how.
So tapping into various funding streams.
Exactly. Grants, subsidies, tax incentives, all designed to encourage cleaner fuels.
Right.
Plus, they worked with private investors to help fund some of the big infrastructure costs and speed up the tech side of SAF production.
Got it. So development, check.
Mm-hmm.
Production pathway, check. Funding, check. What about actually, flying planes with this stuff, the operational testing?
Right, the moment of truth. That was the next critical phase, extensive operational testing and deployment.
Mm.
They put the SAF through its paces in a whole range of military aircraft. We're talking about recon planes, big transport aircraft, even high-performance fighters.
So across the board.
Pretty much. And these weren't just, gentle test flights. They were really pushing the envelope, flying in different weather, different operational scenarios, really stressing the fuel and the engines. They measured everything: fuel burn, engine thrust, emissions, and importantly, any effects on maintenance schedules down the line. And of course, they had to train up the pilots and the ground crews on how to handle SAF properly. That's key too.
Okay, so after all that incredibly thorough testing, what did the data actually show? Did the SAF stack up against traditional jet fuel?
Well, the results from the data validation phase were actually very encouraging. They did direct comparisons head-to-head against conventional fuel and the SAF-powered aircraft. They showed basically equivalent performance, same thrust, same fuel efficiency, same reliability, which is exactly what you need.
Equivalent performance, okay. But the big win was emissions, I assume.
That was the really compelling part. They saw massive reductions in life cycle greenhouse gas emissions. We're talking reductions of up to 80% compared to the old petroleum-based fuel.
80%, that's huge.
It really is a game changer from an environmental perspective.
Okay, performance is there, emissions are way down. What about the practical side? Getting the fuel where it needs to go, the supply chain.
Yeah, they looked hard at the supply chain resilience, and the analysis showed that actually integrating SAF was quite feasible. It didn't require massive disruptive changes to the existing fuel logistics. And importantly, they found SAF supply could remain stable even if, the traditional oil markets got choppy. That's a big deal for military readiness.
Absolutely. Predictability and stability are paramount there.
So beyond just the technical and logistical wins, were there broader strategic gains from using SAF?
Oh, definitely. The environmental and strategic assessment highlighted a few key things. Obviously, cutting the military's carbon footprint is important, lines up with national goals, global goals. But strategically, adopting SAF helps diversify their fuel sources. That means less reliance on foreign oil, which can be, unpredictable.
Right, enhances energy security. Precisely. It makes them more resilient if there are geopolitical crises or supply chain problems. It strengthens national energy security overall.
It sounds like this whole effort has produced some tangible result then, some real achievements. What are the big ones?
Yeah, one really standout achievement was successfully transitioning an entire fleet of reconnaissance aircraft over to using SAF for their regular missions.
The whole fleet, wow.
Yeah, that was a huge milestone. It really proved the concept works in demanding day-to-day operations, not just tests. It set a really important benchmark for what could be done across other parts of the military.
That is a concrete impact
Yeah.
and the wider strategic picture.
Well, like we touched on, by proving they can reduce their reliance on traditional oil, they've definitely boosted national energy security. Being less vulnerable to global oil price shocks or supply cuts, that's a significant strategic plus in today's world.
And I bet this kind of pioneering work gives them a bit of an edge, reputation-wise.
No question. This initiative really positions that defense contractor as a leader in, sustainable aerospace innovation. That's good for their image in the defense world, sure, but it also opens doors, new opportunities with government contracts, potentially commercial airlines looking for SAF expertise, maybe even international partners.
Okay, so as we kind of pull back from this deep dive, what are the absolute key takeaways from this contractor's journey with sustainable aviation fuel? What should you, our listener, really hang on to?
Well, looking at the source material, a few things really stand out. First, those strategic partnerships, government, industry, research, they are absolutely essential. You need that collaboration for resources, infrastructure, getting through the regulation.
Right, can't go it alone.
Second, government support incentives, clear policies, steady funding. It's critical to get over those initial cost hurdles and really push F into the market. Third, demand is growing. The whole world is looking for sustainable solutions, so SF isn't just nice to have anymore, it's becoming a competitive factor. Fourth, you need that continuous R&D investment, making sure SAF always meets the super strict performance and safety needs, especially for tough military flying. Fifth, the environmental impact is real. SAF is a powerful tool for cutting aviation's carbon footprint, helping hit those net zero targets.
A big piece of the climate puzzle.
Definitely. Sixth, long-term thinking is key. You need sustained policy support and investment in production to make SAF widespread and affordable. And finally, really, this whole effort just shows the incredible potential SAF has. It could truly revolutionize both commercial and military aviation. It points towards a more sustainable, more secure future for flight and defense.
So yeah, we've seen how this contractor really dug in, tackled the huge challenge of making military flight more sustainable using SAF. They navigated some serious technical issues, built those crucial partnerships, and got real results, demonstrated real progress.
It really hammers home the point, doesn't it? That even sectors with the absolute toughest requirements, like the military, aren't just talking about sustainability, they're actually doing it. And because military fuel needs are so extreme, the fact that SAF can work there, it makes you really sit up and notice the potential everywhere else.
It really does make you think bigger picture, right?
Mm-hmm.
If SAF can handle fighter jets,
Yeah.
what does that signal for its potential in, I don't know, other high-performance fields?
Yep.
And maybe what could a future look like where we're genuinely powered by sustainable, independent energy sources across the board? It's pretty fascinating to consider how sometimes the really tough demands of military tech can end up driving innovation that benefits everyone. Something to chew on.